Welcome to the second class of Bright and Light Education Hub. So today we are going to learn about the digestion of carbohydrate. So before we go into the chapter, we should first know about the carbohydrate digestion. So basically carbohydrate digestion is the breakdown of disaccharides and complex carbohydrate into monosaccharides for absorption. Although not all are completely absorbed in the small intestine like fiber, but digestion of carbohydrate begins in the mouth with the salivary amylase released during the process of chewing. So in the next part, we are going to know about the digestion of carbohydrate in mouth or oral cavity. So as you chew a bite of food, you are using mechanical digestion to begin to break into smaller pieces and mix it with saliva produced by several salivary glands in the oral cavity. Some enzymatic digestion of starch occurs in the mouth due to the action of enzyme like salivary amylase. This enzyme starts to break the long glucose chain of starch into shorter chain as small as maltose. Now in the mouth there are digestive juice like saliva, and it contains some enzymes like ptyalin, salivary amylase and maltase. So it acts upon starch and maltose and gives an end product of maltotriose, isomaltose, maltose, glucose. Now in the next part we are going to know about the digestion of carbohydrate in stomach. So due to the low pH in the stomach, which inactivates the salivary amylase, so it no longer works once it arrives at the stomach, although there is more mechanical digestion in the stomach and there is very little chemical digestion of carbohydrate here. So the digestive juice which is present in stomach gives an enzyme which has a non-enzymatic action, HCl, which is secreted in the stomach, and it acts upon sucrose and it gives an end product of glucose and fructose. So basically HCl is secreted, which is gives a nature of non-enzyme. Okay. Next we are going to know about the digestion of carbohydrate in small intestine. Most carbohydrate digestion occurs in small intestine, and like pancreatic amylase is secreted from the pancreas into the small intestine, and like salivary amylase it breaks starch down to smaller oligosaccharides which contain 3 to 10 glucose molecules and maltose. So in small intestine we have digestive juices like pancreatic juice, which has enzymes like pancreatic amylase and maltase, which acts upon starch and dextrin and maltose and gives an end product of maltose and glucose respectively. We have another digestive juice in small intestine, that is intestinal juice, which has enzymes like intestinal amylase, isomaltase, maltase, dextrinase, sucrase, lactase, which acts upon the substrate like starch, isomaltose, maltose, dextrin, sucrose, lactose, and gives an end product of maltose and glucose. Glucose plus fructose in case of sucrase, and glucose plus galactose in case of lactase. Okay, so these are the chemical actions that take place in small intestine. So here I have mentioned few, like in the previous yes, maltose is digested by maltase forming 2 glucose molecules. Again, lactose is digested by lactase forming glucose and galactose. Sucrose is digested by sucrase forming glucose and fructose. So here is the digestion of carbohydrate in small intestine, which digestion and absorption of carbohydrate is in the small intestine are depicted in a very simplified schematic below. Like the diagram is given here, which symbolizes the enzymatic action that takes place in small intestine, right? And in the next part I have given the digestion of carbohydrate in large intestine. So any carbohydrates that are not digested in the small intestine, mainly fiber, passes into the large intestine, but there is no enzymatic digestion of these carbohydrates here. Instead, bacteria living in the large intestine, sometimes called our gut microbiota, ferment these carbohydrates to feed themselves. So fermentation causes gas production, and that's why we may experience bloating and flatulence after a particular fibrous meal. So fermentation also produces short-chain fatty acid, which our large intestine cell can use as the energy source. Over the last decade or so more, some researchers have shown that our gut microbiota are incredibly important to our health, playing important role in the function of our immune response, nutrition and risk of disease. A diet high in whole food sources of fiber helps to maintain a population of healthy gut microbes. So here I have given a diagram which has all the locations of carbohydrate digestion, the enzymes which act upon the substrates and the form of dietary carbohydrate. Okay. Now the next part, I have given a summary of carbohydrate digestion. Number one, after eating, nothing needs to happen in the digestive tract to the monosaccharide in a food like grapes, because they are already small enough to be absorbed as it is. Now the disaccharide in that grape or in a food like milk are broken down with the help of enzyme in the digestive tract to monosaccharide like glucose, galactose and fructose. After that, the starch in food is broken down again through the enzyme in the digestive tract to glucose molecules, and lastly fiber in food is not enzymatically digested in the digestive tract because humans don't have enzymes to do this. However, some dietary fiber is fermented in the large intestine by gut microbes. I have provided some notes which will help you in making your class notes and which will help you to prepare yourself for the exams. You can refer to these diagrams. And thank you for watching. Stay tuned with us for the next video. Thank you.